What's up, you freaking geniuses? So in this video, I'm going to teach you how to find the mass of an object using the density formula, right? And we're going to go over a little word problem here to cover this topic. So the problem here just says, the diagram shows the dimensions of a standard gold bar at Fort Knox. Gold has a density of 19.3 grams per cubic centimeter. Find the mass of a standard gold bar to the nearest gram. Okay, so let's start nice and easy. Let's just write out the density formula. So the density of an object is equal to the mass divided by the volume. Now remember, the problem is asking us to find the mass of this gold bar. So M is what we're looking for. So we can rearrange this formula and solve for M. So if we want to isolate M, the mass, we can get rid of this V in the denominator by multiplying both sides by V. So I'll multiply this side by V and multiply this side by V. All right, so then on this side, the V's cancel out and we're simply left with the mass is equal to the density times the volume, D times V. All right, so let's plug in what we know for the density and the volume. So here the problem tells us that gold has a density of 19.3 grams per cubic centimeter. All right, so let's plug this in for the density. So the density is 19.3 grams per centimeter cubed, right, or cubic centimeter. All right, so that's the density right there. And now we're going to multiply that by the volume of this gold bar. Okay, but something might stand out to you right now, and that is the dimensions, right? So all these dimensions are in inches. And as you can see, the density that we were given is in centimeters. So we need to convert all of these dimensions from inches to centimeters. And the way that you do that is, first you need to know the conversion between inches and centimeters. So 1 inch is equal to 2.54 centimeters. Okay, so in order to use this conversion to convert each of these dimensions, let's just start with this one right here, the 7 inches. So we're going to say 7 inches, and then we're going to multiply it by this conversion. And we're going to put this conversion in a fraction, right? So what goes on top and what goes on the bottom? Well, you always want the same units on opposite sides. So since we have inches on top over here, we want inches on the bottom. So here we want this 1 inch. We want to put 1 inch on the bottom, and then that means we want to put the other one, 2.54 centimeters, on top, okay? And the reason we want to do that is because now when we multiply these together, you can see we have inches on top and inches on the bottom, so those cancel out. And then we just have to multiply straight across. And I'm going to move this back a little bit just to give ourselves a little extra room here. So again, just multiplying straight across. On top we have 7 times 2.54, and that's equal to 17.78. And then what are our units? Centimeters, right? We still have our centimeters right there. And then on the bottom, we just have a 1. So this is all going to go over just 1. But dividing by 1 doesn't do anything, right? It doesn't change anything. So if you want, we could just leave it like this, 17.78 centimeters. Okay, so not too bad, right? Let's convert these last two dimensions. So first we have this 3.625 inch, right? So again, we're going to multiply that by our fraction right here, 2.54 centimeters over 1 inch, right? So again, the inches cancel out, and then you just multiply straight across, right? So then here, 3.625 times 2.54 is approximately 9.21. And again, our units that we're left with are centimeters, right? And then lastly, 1.75, right? So 1.75 inches times 2.54 centimeters over 1 inch is equal to, right, these cancel out. So multiplying straight across, this is equal to approximately 4.45 centimeters. All right, great. So now that we converted these, now we can use these dimensions to find the volume of this bar. And as you can see, this bar, it's a rectangular prism, right? And to find the volume of a rectangular prism, or essentially a cube, or something that looks like a box, the volume is going to be equal to the length times the width times the height, all right? So here, we just have to multiply all of these three dimensions together, right? This is the length, right? 7 inches we turned into this. This width right here, 3.625, we turned into 9.21. And then the height, 1.75, we turned into 4.45, right? So if you multiply all these three together, you'll get that these are approximately equal to 727.60 nice. And our units are centimeters cubed, right? Because we're working in three dimensions, length, width, height. All right, now I'm gonna move all of this to make some room. All right, now we know what the volume is in centimeters of this gold bar. So now we can plug it into our formula for the volume. All right, so this is all equal to m. All right, now I'm gonna actually scroll down a little bit so we can multiply these guys together. So one thing that you might notice before we multiply these together is that we have the same units on opposite sides, right? So we have centimeters cubed down here and centimeters cubed up here. So those cancel out. Okay, so now if we just multiply straight across what we have left, 19.3 and 727.69, that's going to be equal to 14,044.38 approximately. And what are our units that we have left? Grams, right? So this is equal to m, the mass. Boom. So if you found the video helpful, make sure to leave a thumbs up down below. And if you have any questions, let me know in the comments section below.